Today we're going to talk about minerals. Some cool ones there. So your heading is minerals. How can minerals form? Go ahead and write this. There's some different ways we can form minerals or find them. So how can minerals form? The first way is the cooling of magma. Cooling of magma. Just a reminder, please take good notes because this will be an open note test. So, deep in the earth we have magma, which is liquid hot rock. And when it comes to the surface, it's going to cool. And when liquid hot rock cools, it hardens. So that's one way minerals can form. I would probably make a note of this as well. You can shorten this up, but if magma cools quickly, it's going to make small crystals. And if it cools slowly, it's going to make large crystals. So quickly, small crystals, slowly, large crystals. Evaporation. It's one way minerals can be formed. So I could take ocean water and evaporate it and I'd be left with salt crystals. Salt is a mineral. So with magma cooling and forming minerals, and then evaporation forming salt minerals. And the third one, precipitation. I don't mean rain, snow, sleet, or hail, but precipitates are heavy, they're dense, and they're going to sink to the bottom of water most of the time. So they're more dense and they're going to sink to the bottom of water. So those three things: cooling of magma, evaporation, and precipitation. Mineral requirements. Why don't you write this? Requirements: all mineral must have these characteristics. So let's say I give you a chunk of something and I ask you, is this a mineral? You can figure it out. First of all, is it a crystal? Does it have a crystalline structure? We'll get into that a little bit later down the road. Is it homogeneous? Doesn't mean it's a mixture, but it means homogeneous means it's the same all the way through. I used the example with the homogeneous mixture of Mountain Dew. The first drink of Mountain Dew out of a can or a bottle is the same as the last drink and everything in between. It's homogeneous. Well, if I have a mineral, let's say I have a chunk of salt, and I lick it until it's gone, the first lick of salt is going to be the exact same as the last lick. It is homogeneous, it is the same all the way through. It needs to be inorganic. Now in science, organic means alive, made of living stuff. So inorganic is non-living. It was not made of living stuff. So an example of organic material would be like wood. Wood is an organic material. It was once living. Rocks and minerals were not once living. So we're not talking about no chemicals or whatever like food. We're talking inorganic means not living. Natural, not man-made. I can't make diamonds. And then it has to be a solid. Okay, you can't have liquid mineral or gaseous mineral. It needs to be a solid. So I always remember chins, crystals, homogeneous, inorganic, natural, solid. You don't need to write this, but there are mineral groups. So silicates are going to be made up of some elements. And yes, you guessed it, silicone and oxygen. Anything that ends in ates is made up of oxygen. So carbonates would be carbon and oxygen. Oxides would be just oxygen. So if a mineral is a sulfide, made of sulfur, sulfates would be, anything with ends with ates would be oxygen, sulfur and oxygen. Halides, kind of a mixture of some things, chlorine, bromine, fluorine, iodine. Hydroxides, so hydrogen and oxygen. Phosphates, phosphorus and oxygen. And then native elements that are also minerals would be like gold, silver, copper. Those are minerals, they're natural. You would find a chunk of gold or silver or copper in nature. That is it for today.